In this chapter, we are going to do some 2025 questions from the chapter Vector, class 12, and most of it has been tested in previous board examination. Let's begin with the first question. We have to find a vector in the direction of this vector, right? And whose magnitude, whose magnitude is 21 unit. So let's understand if I have to find a vector in the direction of the given vector, right? So in order to find a vector, right, in the direction of this given vector and having a magnitude, how much? 21 units. First, we'll be finding a unit vector. So in order to get a unit vector here, what you'll do here, let's say if I tell you this is a given vector A, and if I have to find 21 unit vector along this direction. So what you'll do, first you'll find a one unit vector in this direction. So once you get a one unit vector in this direction, say a cap, and if I multiply this with 21, that should give us a vector of 21 unit magnitude in the direction of the given vector. So this is what I'm going to do. And if I take this vector as say a vector here, then what you know that a cap is what? A cap is a vector divided by its magnitude, that is a magnitude. First, I'll obtain a magnitude, which is what? Under root a square plus b square plus c square. Needless to say that what is ABC? That is 2, 3, and 2 minus 3 and 6. So it's going to give you 2 square, which is 4, minus 3 square is 9, and 6 square is 36. So A magnitude comes out to be how much? Under root 49. So the A magnitude will give you how much? 7. Once you get this, now as I said, we are going to get a unit vector. So A cap is what? Vector A divided by 7. So 2i minus 3j cap plus 6k cap, that divided by 7. But check here, we have to get of 21 magnitude. So in the next step, we'll be multiplying 21. So the required vector is what? 21 multiplied by this, which is 2i minus 3j minus 3j plus 6k cap, that whole divided by 7. So I can reduce this by 3 times and finally multiplying what we are getting 2 into 3 is what? 6i cap minus 9j cap plus 18k cap. So we'll say that this is the required vector. Now we are on the second question. It says find a vector or vector A of magnitude 5 root 5 making an angle of pi by 4 with x-axis, pi by 2 with y-axis, and an acute angle theta with the z-axis. Now, as we have discussed previously also that in order to get a vector A of how many? 5 root 2 magnitude. So we'll be multiplying this with the A cap. That means first we need to get A cap, which is which is what? One unit vector, right? In the direction of this vector A, and then we'll be multiplying with 5 root 5. What you should also know that A cap is what? A cap is Li plus Mj cap plus K cap. That's Lmn K cap, where what is Lmn? Lmn are the direction cosines. And what are direction cosines? These are the angle made by the line with the positive direction of x-axis, y-axis, and z-axis, right? So let's first obtain L here. As you can see that the angle made by the line with the positive direction of x-axis, with the x-axis, not a positive direction necessarily, is pi by 4. So cos pi by 4. Cos pi by 4 is what? This is cos 45 degrees. This is 1 over root 2. And if I get m, which is cos beta, and beta is as per the question given as how much it is? Pi by 2. And cos pi by 2 is what? Cos 90, and cos 90 is 0. Similarly, now we don't have Lm, n is not given here. So, but we have a relation between this Lmn, that is L square plus m square plus n square is equal to 1. So I'll be replacing L. This is 1 by root 2 square is 1 by 2. 0 square is 0. And what is n? N square is n square only. So this results to give you n square as 1 minus half, which is half. So n will give you plus minus 1 by root 2. Now what next we are going to do is to obtain this, right? Replacing element with this. So in order to get a cap here, so a cap is what? L, which is 1 by root 2 times I plus m. M is 0. So let's say write 0j plus n, which is just taking the acute angle. So I'll take positive, and this is n. So once you get a unit vector, you have to find a vector of magnitude 5 root 5. So you'll be multiplying 5 root 5 to this. So this when multiplied by 5 root 5, I'm talking about this vector, right? So as I discussed that we are, in order to get a 5 unit vector in this direction, we'll be multiplying this vector with 5 root 5. So let's say if I do so here, what you'll get, this one multiplying, right? This one multiplying here, it should come as, if I root to get cancelled, so it's 5i, as 0 multiplied by any number is 0 only, and then it should again give you 5. And this is not n, this is k cap, right? I, j, k cap. So it'll give you this as the required answer for this question. In the third question, it says, write a unit vector in the direction of sum of these two vectors. So first, let's say, first of all, this is vector A and this is vector B. We have to first find this vector. So what I'll say that, let's say C be a vector which is sum of these two vector A plus B. And what we have to find, a one unit vector along this direction. So actually we have to get C cap. So C cap is what? That is vector C divided by the magnitude of C. So let's say first obtain C here. The vector C can be obtained as A plus B. That is, if I add directly here, that is this and this, adding their coefficients. So this is 2 plus 2, which is 4i, and 2 plus 1 from here, 2 plus 1. So it's 3j, and minus 12k, minus 5, minus 7. So we got C. Now we have to get C cap, and for that I need to get the magnitude of C, which is under root 4 square 16, under root 3 square 9, and 12 square is 144. So it's coming as how much? This is 169. So under root 169 is how much? So we'll get C cap here as 13. And as we have to get, sorry, we got C magnitude as 13. So in order to get C cap, it is vector C, which is 4i plus 3j minus 12k cap, that divided by 13. So I may write 1 over 13 like this. I mean to say writing this, or writing 1 over 13 over here. That will also work. So this is how we'll do the third question. In the fourth question, we have to find the value of this P, right? P is over here. So we have to find the value of P for which the vectors this and this are parallel. So what you know that two vectors are said to be parallel if their direction ratios are proportional, and the converse is also true. So now we can say that we are given these two vectors and will be parallel, so their direction ratios will be what? Direction ratios will be proportional. So if I obtain the direction ratios of this vector is what? This is 3, 2, and positive 9. And the direction ratios of this vector is what? This is 1, minus 2p, and 3. As we discussed that they will be proportional direction ratios. So a1 over a2, like from here, should be equal to what? And this is minus, I just noticed this is minus. So this is b1 over b2 should be equal to C1 over C2. Let's simplify any one of them. So I'll get what? On cross multiplication of these two, I'll get what? P is equal to minus 1 over 3. So that's a very simple question to get the value of P in this case. Let's move to the next. In the next question, it says write the value of cosine of the angle with this vector A, which makes with the y-axis. So first of all, what you know as a unit vector is represented as Li plus Mj and Nk cap, where Lmn are the direction cosines. And if I talk about just M, what is N? It is the M. If I write, what is M here? M represents cos, gamma, alpha, beta. It should be beta, cos beta. And this is the angle made by the vector with that of the y-axis. Well, this makes for the z-axis and so on. So what we are going to do is simply to get A cap here. And A cap is what? Vector A divided by the magnitude A. So let's obtain A magnitude, which is what? A, from here, right? These direction ratios are 1, 1, 1. So it's 1 square, which is 1 plus 1 square, which is 1 plus 1 square. So it's coming out to be root 3 here, right? So we got A magnitude here. And later what we have to find out is A vector, a unit vector along A. So I'll be writing A cap, which is from here. That is A vector, which is I plus J plus K cap, that divided by the magnitude A, which is under root 3. So now we can write it as 1 over under root 3I plus 1 over under root 3J and 1 over under root 3K cap. And what is this? This is M, and M is cos beta. So we'll say that we have to find not the angle, right? Cosine of this. So cosine of this is same. That is 1 over root 3. So this is the answer in this case. Now, question number 6 is similar to the fifth. That's why I did not erase the working of this. Let's see. It says find the angle between the x-axis and the vector this. So the difference between the previous and this question is that over there we have to find cosine of this, and this time we have to find angle. So I repeat, cosine is, LMN. So M is going to be what here? Well, this time they're asking for x-axis. Sorry. So we'll be going for L, and L is what? Cos alpha. But then unlike previous part, we don't have to get cosine of this. We just have to get the alpha here. Now check here. For this case, the alpha, L is cos alpha. And what is L over here? This is 1 over root 2. So I'll say that cos alpha is how much? 1 over under root 3. But then we have to get alpha as decided already. So we'll be writing cos inverse 1 over root 3. And the rest is same as the rest of the working will remain same. Let's move to the next. Question number 8. It says write a unit vector in the direction of the vector PQ, where P and Q, the vector P and Q with the positions given as the point 1, 3, 0 and the other as 4, 5, 6 respectively. Now, first what we are going to do here, let's say if I write on this, what I written here, what we are going to do is obtain PQ vector first, and PQ is a vector, right? PQ vector. And we are going to use this relation, that is x2 minus x1 I plus y2 minus y1 j and z2 minus z1 k. And once we are obtained, then we are going to get the required vector, that is, which is, it's a unit vector, right? As you can see, we have to obtain a unit vector here, a unit vector. So will be given by this formula called PQ vector, sorry, PQ cap will be equal to PQ vector that divided by PQ magnitude. So let's do one by one. First, I'm going to obtain the PQ vector here. That is, how did we get this? That is x2 minus x1. So this is x2 minus x1. I should show the working here. So the vector PQ is going to be what? x2, which is 4 minus 1 x2 minus x1 I cap plus y2, which is 5 minus 3 j cap, and plus 6 minus 0 k cap. So what we are going to get this vector as 3 I cap plus 5 minus 2, 5 minus 3 is 2, right? 2 j cap and 6 k cap. Now, once we have obtained the PQ vector, we are going to obtain its magnitude, and PQ magnitude is going to be what? That should give you whole under root 3 square, that is 9 plus 2 square, which is 4 plus 6 square, that is 36. It comes out to be 49, under root 49, and that is equal to 7. So now we are simply going to plug in over here, that is the PQ cap is equal to PQ vector, which is 3I plus 2j plus 6k cap, that divided by 7. So this is what we are going to get the answer. In the next question, we have it's given that P and Q are 2 points whose position vector are this and this. So P and Q are 2 points whose position vectors are this. Well, the diagram is not given, right? I just made it. Respectively, write the position vector of R which divides the line segment externally in the ratio 2:1. So in case of external, we have this relation. You may write this also, like you can write this as, you can modify this formula. This is OR vector can be obtained as M times, this is B, that means OQ vector minus N times OP vector, that divided by M minus N. So I should better write down what is A here. A is this, right? A is this, which is 3A vector minus 2B, also can be written as OP vector, and this is OQ vector, which I have taken as B vector here, right? And OR is OR only. So we can simply plug in the value here, right? We are just going to replace this. So I can say that the OR vector here is what? OQ vector into M, and M is what? As can you see the ratio, it is 2:1 externally. So this is 2 times OQ vector, and OQ vector, as you can see from here, that is A vector plus B vector minus 1 time, as you can see N is 1, OR vector, OP vector, which is 3A minus 2B, and that divided by M minus N. So that is 2 minus 1. So finally it results to give you how much? This is 2A vector plus 2B vector minus 3A vector. Yeah, it's minus 3A vector and plus 2B vector. So it's what? 2A minus 3A is minus A, and this is 4B. So we can say that this is the required vector which divides the OP vector and OQ vector in the ratio 2:1 externally. The next question is for internal division. It says A and B are 2 points whose position vectors are given. So this is the first one, say OA, other is OB. We have to write the position vector of P which divides the line segment internally in the ratio. So if I modify the diagram here, we had to get what? P. So I'll be writing this R as P. That means we have to obtain OP vector, right? So I'll be modifying this as per the question. I will be writing this as OP vector here. So this is OP vector here. And this is OA vector, and this is OB vector. So using this relation here, that is OR vector, if I write what is OR vector? OR vector should give you M times OB vector, B is OB vector, right? Plus N times OA vector, that whole divided by M plus N. So let's replace these values here. As you can see, M over here is what? 1, and this is 2. So this is what? M first, which is 1 times OB vector. And OB vector is what? This one, the second one is the OB vector, which is 6B minus A vector plus n is what? 2 here. As per the question, it is 2 here times OA, and OA is 2A minus 3B. That whole divided by m plus 1 is how much? 3. That is 2 plus 1. So we can simplify it further. This is 6A. I'll do it. Okay, let me show with the proper working. In the next part, we are just going to multiply here. This is 4 times A minus 6 times B, that divided by 3. Now further, if I write the remaining part over here, that is OR vector, what do we get here? 6B minus 6. So this get cancelled here, right? So we get 3A vector that divided by 3. So we are simply getting A vector as the answer for this part, 14. The next question is to find the scalar component of AB with the initial point A and the terminal point is given here. So let's say if I make a vector here, say this is say A with the initial point as what, 2, 1, and B with the terminal point as minus 5, 7. So how do we represent this is AB vector as like, it's x2 minus x1 I'm talking about the representation of AB vector, and then y2 minus y1 j plus z2 minus z1 k component. Now, what is ABC here? ABC are these the scalar component, right? Scalar component are these only. So since we have to find scalar component, we'll be finding x2 minus x1. Right, the scalar component are these three are called the scalar component. So the scalar component in the first case is what? X2 minus x1. X2 minus x1. So minus 5 minus 2, which is equal to minus 7. Just the scalar component and not the vector. And similarly, this is y2, as you can see, y2 minus y1. So y2 minus y1 is going to be what? 7 minus 1, that is equal to 6. So we just have to find, and there is no z component here. So we will declare minus 7 and 6 are the scalar component of this AB vector. In the next question, he says, what values of A? I think A is not a vector here, so printing. A is this, right? A scalar component for the vectors, this and this are collinear. So what is the condition for two vectors to be collinear? So let me write down. So two vectors are said to be collinear, right? Two vectors we say are collinear. Yeah. So when vector A is lambda times B, where lambda is some scalar quantity. So I'm going to take this as A and this whole vector as the B vector here. So I can use this relation, that is vector A, which is 2i minus 3j plus 4k cap is equal to lambda times vector B, and the vector B here is AI plus 6j minus 8k cap. Now comparing their coefficients, like comparing the coefficients of A here, this is going to give you what? Comparing the coefficients of A, right? Just the A. So we'll get what here? We'll get lambda, one second. Yeah, we'll get 2 is equal to lambda times A. Comparing the coefficients of J, it is minus 3 is equal to minus 3 is equal to lambda times 6 on opening this bracket. So from here, what you can see that lambda comes out from the second, right? Lambda will give you how much? Minus 1 by 2 on transposing 6 to the other side. Now, if I replace this lambda over here, let's say this is 2 and I'm replacing this lambda with minus 1 over 2 times A. So on cross multiplication, we get A as what? Minus 4. Right. So we'll say that minus 4 is the value of A in this case. In the next question, we have to find the direction cosines of this vector. So what are direction cosines? These are L, M, N. And if I write a unit vector, let's say if I write unit vector, its scalar component are Li plus Mj plus nk cap. That means if we are given a vector A and if I convert them into a unit vector, their scalar component will represent element. So let's say if I get that unit vector that is A cap, which is vector A divided by the magnitude of A, let this be vector A. I've taken this as vector A. So what is its magnitude? Let's obtain its magnitude, which is under root minus 2 square, 4, 1 square is 1, and minus 5 square is 25. So it's to give you how much? This is under root 30. Now from here, what I'm going to write is that A cap, which is A divided by, so it's minus 2 over 30 under root 30 times I plus 1 over under root 30 times J and minus 5 over under root 30 times K. And as I discussed, now if I compare this with this, we get LMN. So L, M, and N is given. So we can say that the direction cosine is what we had to get. So I'll say that direction cosine here will be equal to minus 2 over under root 30, comma 1 over under root 30, comma minus 5 over under root 30. This is what is our answer. In the next question, it says, write the position vector of the midpoints of this vector P and Q. Well, so we can say that the midpoint is what? Let's say if I take whatever the midpoint here should be give you that is OP vector plus OQ vector that divided by 2. Right? That's a special case of section formula. So OP vector I can figure out from here. The position vector of OP should give you how much? That is 2I. This is 2I plus 3j cap plus 4k cap and plus OQ vector as I can see from there. This is 4I plus j cap minus 2k cap and that whole divided by 2. So this is 2 plus 4 that is 6I cap plus 3 plus 1 which is 4j cap plus 4 minus 2 which is 2k cap that whole divided by 2. And if I individually divide it, I'll get what? 3I plus 2j plus k cap. So this will be the answer for this. The position vector here. Let's say you can take the position vector as say whatever you can write as OPQOR as the position vector. Then OR is going to be this. In the next question, it says write the position vector of the midpoints of this vector P and Q. Well, so we can say that the midpoint is what? Let's say if I take whatever the midpoint here should be give you that is OP vector plus OQ vector that divided by 2. Right? That's a special case of section formula. So OP vector I can figure out from here. The position vector of OP should give you how much? That is 2I. This is 2I plus 3j cap plus 4k cap and plus OQ vector as I can see from there. This is 4I plus j cap minus 2k cap and that whole divided by 2. So this is 2 plus 4 that is 6I cap plus 3 plus 1 which is 4j cap plus 4 minus 2 which is 2k cap that whole divided by 2. And if I individually divide it, I'll get what? 3I plus 2j plus k cap. So this will be the answer for this. The position vector here. Let's say you can take the position vector as say whatever you can write as OPQOR as the position vector. Then OR is going to be this. In the next question, it says ABC are the vertices of a triangle. Then what are the value of AB vector plus BC vector plus AC vector? So for that, what we are going to do is to first to make a triangle. I made a triangle over here and named it as ABC. And using this triangle law, right, of vector addition, what you know that this is I should show you first. This is AB vector plus BC vector should give you how much? AC vector, right? AC vector here. So using this relation, what I can do, I can write here that AB vector plus BC vector is equal to AC vector and not CA. Now further what I can do, let's say AB vector plus BC vector is as it is. What I can write, you know that AC vector is same as minus CA vector. So I'll replace AC with minus CA vector, and this I got from the idea from here. Now check in the last step what I can do. I can write AB vector plus BC vector. On transposing this to the left hand side, it will become positive CA vector and nothing on the other side. It means 0. So we had to get the answer of this, right? And this is coming equal to 0 in this case. The next question says if A be this vector and B is this, then we have to find a unit vector in the direction of A minus B. So what we can see here that let's say if I obtain C vector here and I took C vector, let C be the vector which is equal to A minus B, and then we have to obtain C cap. Well, C cap is what we have to get, and you know that C cap is what? That is C vector divided by its magnitude, divided by C magnitude. Now, first what I'm going to do is to obtain the C vector here, and C vector is obtained as A minus B. So what is A, which is I plus 2j cap minus k cap, and then we'll place a minus B, which is 3I plus j minus 5k cap. Now simplifying this, what I'm getting 1 minus 2, which is 1 minus 3, which is minus 2I, 2 plus 1, which is 3j cap, and minus 5 and minus 1 will give you minus j k cap. Now, since we have to get its magnitude as well as this is what under root 2 square, which is 4, under root 3 square is 9, and under root 6 square is 36. So C magnitude is under root 49. That results to give C magnitude as 7. And as I said, we have to get C cap, right? This is C cap. This is C cap here. So C cap is what we had to obtain. And as I said, it's a C vector. C vector is what? This is C vector. So this is 2. This is minus 2I plus 3j cap minus 6k cap, and that divided by 7. So this would be our answer in this case.